Okay, this is the slope review for mastery test. So a few things to go over before we start. So calculate that given our points. Given our points, go back here. We can say that it is the change in our y values over the change in our x. And this is a Greek symbol here representing change. So delta y over delta x. You may have heard that before. And we also use the variable m when we're talking about slope. So if we look at this table, the average bills for the given number of dinners at Simone's restaurant, if the rate is constant, so that means it's going to stay the same, and you graph this relationship with the number of people along the x-axis and the bill along the y, which points would lie on the line you get. So to figure out the line for this problem, we need the slope. And our line, we can look at y equals mx. This is going to be a proportional relationship because if I have 0 people, my bill will be 0. I know it would be starting at 0, 0 at the origin. And so this would be the formula y equals mx, where m is going to replace our slope. And so I need to find that slope, that rate within this problem. So I can look at my change in y values. And I can see from 40 to 80, that is a change of 40. 80 to 200, that's a change of 200. Here's a change of 1, change of 5. So I just need one set of the change in y over our change in x. And if I look at that, so my slope for this table, my change in y was 40 over the change in x, which was 1. I could have also done 200 over 5. 200 over 5 is also going to simplify to 40 over 1. So everything in this table is showing me a rate of 40, or multiplying by 40 here, times by 40. And so if I replace that, I would have y equals 40x to represent my equation for this table or the line. And then they're asking which points would actually fall on this line. Well, if they fall on the line, they need to make these x and y values true. And given a table, can kind of use these x values to see if they would in fact give me that y value. So like here I have 12. If I'm using y equals 40x, so I'm going to take my x value, multiply it by 40, and that should give me 480. That's not this point here. It's 460 instead. So I know that one doesn't work. That does not fall on this line. Let's try the 20. If I take my x value, multiply it by 40, my y value would be 800. So that one works. That's good. 24. Let's see. 24 times 40 would be 960. Not 1020. This one does not work. 27 times 40 is 1080. So that point works. My pen is not working too well there. And the last one, 28 times 40, I should be getting 1120. And so that point does not work. So it's only these 2 points that would fall on the line to represent this situation here. Now let's take a look at a couple more here. Keith is the leading goal scorer for a hockey team in the league. Last season, he scored 42 in 8 games. Assuming he scores goals at a constant rate, what is the slope of the line that represents this relationship relationship if the number of games is along the x-axis and the number of goals is along the y-axis. So we can think of our goals compared to our games, goals per games. And again, that is our y over x there. So I'm going to be taking the number of goals, 42, dividing it by how many games. And that's going to give me 0.512. We could also, now notice when I divided that out, it gave me a decimal. All my choices here are in fractions. So we could also just simplify this. Both of these could be divided by 2. So if I were to divide 42 by 2 and then 82 by 2, that would give me 21 over 41. Okay, so sometimes you might see your rate as a fraction, sometimes as a decimal. In this case, we would choose A. The equation R equals 6T gives the number of albums released, R, by a record label over time in years T. If you graph this relationship with the time along the x-axis and the number of albums along the y, what points lie on the resulting line? So again, we can use this equation here, and they're saying that time is your, would represent more of your x-axis, and then your number of albums released, R, is going to be your y-axis, x and y. All right, and now we're using this R would be taking the T value and multiplying it by 6. So let's see if these work, which ones work. If I use 7 as T, 7 times 6, I should get 42. So this point does not work. 8. 8 times 6 from our equation, that gives me 48. This one works. 9. 9 times 6 should give me 56. This point does not work for this situation. 12 times 6 should be 72. Does not work. And then last one, check 13 times 6, and yes, that is 78. And so these 2 points would lie on the line. They make this equation true both for the R and T. All right, next one, a school conducts 27 tests in 36 weeks. Assume the school conducts tests at a constant rate. So there's your rate again. What is the slope of the line that represents the number of tests on the y-axis and the time in weeks on the x-axis? So we're doing y over x, test, the y-axis is the time, and the x-axis is the, oops, I'm sorry, got that reversed. Redo that one. Sorry, the y is our time. Test, y is our test. So test, there we go. And the time in weeks is on the x-axis. So it's going to be the number of tests, which was 27, over the number of weeks, which was 36. So how many tests per week? And if I divide both of those by 9, they both look divisible by 9, we would get 3/4. I noticed all my answers were in fractions there. All right, next one. Irvin sells vintage cars. Every 3 months, he manages to sell 13 cars. Assuming he sells the cars at a constant rate, what is the slope of a line that represents this relationship if time in months is along the x and the number of cars is along the y? So take a look. Our y over x. Y is representing cars. X is our time. So cars per every 3 months here. So he did 13 cars in 3 months. And this fraction is right there for us. Cars per month. All right, Peter walks 3 minutes at a constant rate and travels 330 meters. If we graph this relationship with time along the x-axis and the distance along the y, the slope of the line representing this relationship is, well, I can take my y over x, which would be my distance over time, and we said he goes 330 meters in 3 minutes. So if we divide that out, we would get 110 meters per minute. So that would be 110 there. And then if he walks for an hour, the point on the line that represents the distance he walks with respect to time is, so if he walks for an hour, well, this is per 1 minute. So there are 60 minutes in an hour. So I need to take that 110 meters and multiply it by 60. And that would give me 6,600 meters would be how far he would walk in an hour. Okay, then the next problem. Emily works at a perfumery. She extracts 3 liters of essential oils for perfumes in 2 days. So we can write out our fraction here, our 3 liters in 2 days. And the slope of that, if I do 3 divided by 2, would give me 1.5. You could write it as 1.5. You could leave it 3/2, or say 1.5. So she's doing 1.5 liters per day. And then a point on the line that corresponds to the amount of oil that would be extracted after 5 days. So if 5 is our number of days, I have to do 5 times 1.5. And that would give me 7.5 or 7.5 liters. Okay, another example. If we were to draw lines to join each given point to the origin, so our origin is that point 0, 0. Identify the points whose corresponding line has a slope that is an integer value. So integers are positive and negative numbers not a fraction or a decimal. So let's take a look at this line. If I look at my slope, I can look at on a graph, it's easiest to use that rise over run. So if I'm starting at the origin, on this one I would be going 8 over 2, and that comes out to exactly 4. So yes, for that one. This gives me a slope of 4. The red one here, I would have to go rise of 9, run 3. 9 over 3 comes out to exactly 3. So yes, this slope gives me an integer value. So it comes out to exactly that number, 3. The blue, I would go rise of 8, run of 4. 8 over 4, and that comes out to exactly 2. So this one is a yes. This dark green, rise is 8, run is 5. 8 over 5, that's not going to give me an exact whole number answer, an integer. That would be left as a fraction or a decimal. So this one is a no. How about this one? 7, rise of 7 over 6. Again, that's not going to come out to a whole number answer or an integer. It's going to be left as a fraction or a decimal. So that one is a no. And the last one, we would have a rise of 6 and a run of 7. Again, it would be 7. Left as a fraction. Won't come out to an exact integer. So that would be another no. This next one, they give us some graphs and we have to match which ones go with the slopes here to represent the graphs. I find it easiest to start at the origin with a point and then go along the line and see where is another point that is good where it crosses right at an ordered pair. And I see like right here, because I know it crosses at exactly 9, 2 here. Like here, it looks like it's 7 and 1.5, but I don't know exactly for sure. This one's crossing right at the lines, I can tell. So I'm going to use these 2 points to do my rise over run. My rise is 2, my run is 9. Rise over run, I write it as a fraction. So this one would be the 2/9. This graph, start at the origin. That looks like a good point. And I'm going to go along to look where it crosses again exactly at an ordered pair. This one looks good here. And then I can use those 2 points to go between to do my rise and my run. So 3 over 7 would be my slope. Whoops, 7. 7. This one, again, start at the origin. And as I go along, it looks like it hits right here at 5, 1. So my rise is 1, run is 5. 1/5 would be my slope, rise over run. All right, and then the last one, we want to we need to find the slopes of all of these. That's a lot of work. And then we're going to put them in increasing order. So we're going to just drag the ones with the largest slope to the ones with the smallest slope. Using the points, I can still do my change in y over that change in x. So I want to subtract my y values. So I'm going to find the difference between my y values. 40 minus 30 is 10. And then the change in my x values, 20 minus 15 would be 5. And notice it's important, I'm going to start with this point here both times for my subtraction because those were the larger numbers, just so we didn't get into negatives here. And so I did 40 minus 30, 20 minus the 15. So whatever point you start with on your subtractions, you just want to make sure you do that each time. And that would come out to an integer there too. All right, we can do that same thing. My change in my y values. So 48 minus 32 would be 16. My change in x values, 18 minus 12 is 6. And that comes out to a decimal about with 2.6 repeating. So that one's a little larger. All right. 32 minus 12 for our change in y, so that's 20, over our change in x, 72 minus 27, 45. And if I divide that out, that is our 4 repeating. All right, this next one, 20 minus 15 for our change in our y values. So 5, and then our change in x, 60 over 45, would be 15. And so that is 1/3, or our 0.3 repeating. Okay, this one, 18 minus 2, change in y's are 16. Change in x values, 216. If I divide that out, 16 divided by 216, I get 7/100. So that one has quite a small slope there. All right, this next one, 84 minus 63 for our change in y's. So 21 is our change in y values. Change in x would be 6. 24 minus 18. And that's going to come out to exactly 3.5 or 3.5, since I'm using all decimals here. And then our last one, change in y values. 12 minus 9 is 3. Change in x, 21. And that's 1/7. If we want to keep with the decimals, it'd be about 0.1429 if I round it there. Okay, so we now want to just drag and drop them into the increasing order. So we're going to start with the smallest and end with the largest. So our smallest one would be this one here. We would want that first. Our next smallest, according to our decimals here, would be this point, or this 1/7 here. And going according to our decimals, the 0.3 repeating would be next. Then the 0.4 repeating. 2, 2.6 repeating, and last, the largest slope, the one with the steepest line, 3.5 there, would be our last one to drag over there. Okay, looks like those are some good examples. I hope that helps you on your mastery test for your slope test.